All right, scholars, time to continue our Module 6 notes with Module 6, Lesson 2, Construct a Coordinate Plane. Now, this looks a lot like our last lesson for 6.1, Construct a Coordinate System. We're going to extend the system. We're going to expand on what we learned in the last lesson. For that lesson, everything was just a single line. It was one line stretching off in both directions forever. For this lesson, we are going to add a second line. Although we're not going to call them lines over and over again. I'll talk about that in a moment. Now, the heart of this is still dealing with coordinates. Except, unlike last time, in Lesson 6-1, we talked about a coordinate, just one coordinate as an exact position. Today we're going to be talking about coordinate pairs. A coordinate pair meaning two, right? These are going to be two coordinates that determine a precise and exact, specific. Two coordinates that determine a precise location in two-dimensional space. And we'll talk about that. Okay. I love to repeat over and over again. When you see those lines and line segments, it's only one dimension. You can measure length, and that's it. How long is it? We're going to deal with some width today. We're going to throw that second dimension in. All right. So for our second vocabulary word, we're going to build on this idea of two-dimensional space. We're going to talk about a plane. Now again, a plane, not an airplane, not an aircraft of any kind. Actually, almost quite the opposite. A plane is a flat, so it's not going up at all, it's flat, a flat, two-dimensional surface. A flat, two-dimensional surface. Okay? When we talk about looking for something in two-dimensional space, we represent that with a flat two-dimensional surface. This paper could be considered a two-dimensional plane. It's flat. I can talk about how wide it is and how long it is. Now, realistically, it exists in three-dimensional space. It's got thickness too, although it's not very thick. You can't really see. But for us, in 5th grade math, we're going to treat it kind of as two-dimensional. It's got width. It's got length. Okay. Now, once we have a plane, a flat two-dimensional surface, and we create a coordinate system in it, two coordinate systems actually, then we can go ahead and find specific locations. And to do this, we use, now I'm putting axis here, the plural, and actually, you know what, let's go ahead. We'll put the plural in parentheses. Axes, if you're talking about two of them. Okay. The axes, these are the lines. Okay. A line representing a coordinate system. Now, there are two axes that we're going to be dealing with. And actually, just to make sure this is super clear, I'm going to write system up here and erase this because we're going to do something we don't often do. We have our Roman numeral 2, then we indented for A, vocabulary, then we indented again 1, 2, 3 for those terms. I want to show that the next two things are connected to axis. So I'm going to put them right under here. A. Little a this time, because I'm indenting again. I want to show that these are attached to my item 3. Now, the first one we're going to talk about is the x-axis. This is a horizontal left to right system. So with our x-axis, we're looking at horizontal, straight across. These blue lines are all horizontal. Okay? They run left to right or right to left. Horizontal. They're running across. The x axis always runs horizontally. Your second axis is the x-axis. It's nice, they go in alphabetical order. Horizontal is first, the y-axis comes next. It is therefore vertical, which means up and down. On my paper right here, this pink red line, this would be vertical. It's running up and down. So in that case, it could be a y-axis. The blue would be an x-axis. I'm going to show you a more concrete example in just a moment. We're going to make one together. This vocabulary is very important, and I'm hoping some of it is familiar for those of you who have done some graphing before. But I want you to have it and be able to come back to it, because understanding which is the x-axis, which is the y-axis, is going to be crucial for correctly finding coordinate pairs, for finding those precise locations in two-dimensional space. Now, let's talk procedure. Okay? Let's take a look at how we set one of these up. Now, I'm not going to give it to you step by step like I did in lesson 6-1, because honestly, the steps are kind of the same. For this activity, what we're going to do, we'll use the space between these lines as our unit. That space, if you've got a ruler, at least on my paper, comes out to be a little under 1/4 of an inch. Actually, no, 1/4 of an inch, pretty close. Again, it's like a hair more, actually. It's in there somewhere. About 1/4 of an inch. Doesn't have to be perfect. Now, I need you to skip. Let's skip about 6 lines. Let's do 6 lines. 1, 2, 3, 4, 5, 6. And put a dot right there. Notice I kind of spaced out a little bit here. Like I said, skipping 6 lines going that way. This dot is going to be our origin. So this dot is going to be our 0. Now sometimes you see the little 0 with a line through it, sometimes it's just a 0. Mostly when you see that line, it's just trying to make sure that you know it's not the letter O. It's 0. It's the origin. Okay? I'll go ahead, in fact, and write both. Now, if you have a ruler, it's going to make this next part easier. Go ahead and take your ruler. We are going to measure along one of the blue lines, one of the horizontal lines. And let's go out. We'll go out about 2.5 inches. That should be okay. And when I measured this earlier, we found that this is a little bit bigger than 1/4 of an inch. So I'm just going to mark off every 1/4 of an inch on my ruler. 1/4, 1/4, 1/4, 1/4. 1/4 is 1/4, right? Just like that, until we get to the end. Okay. So now, 2, 3, 4, 5, 6, 7, 8, 9. My 10th line kind of got eaten up by the arrow. And that's okay. That's fine. Okay. We are creating a coordinate system like we did yesterday. This system in particular is running left to right. It's running horizontally. So we are going to call this one the x-axis. The x-axis. Now, as many of you have probably already figured out, if this one is running horizontally, then our vertical one straight up here is going to be our y-axis. Now, the y-axis must be perpendicular. It must be perpendicular, which means it has to form a right angle with this axis. Now, we could use our protractors to measure that. But I actually got pretty lucky on this one. If I line the ruler up with the margin line, that pink line, it gets pretty close to this anyway. So I can just trace this. Please know that like with anything, it doesn't have to be completely 100% precise for your notes. Now, if we were doing a final project or something, precision would be key. But for our notes, I just want you to be able to get a visual idea. Okay. Now, again, not perfect, but close enough. just go ahead and put a little line, there we go, on every blue line. Okay. Now graph paper makes this magical, so if you have graph paper in the next few days, you're going to want to use that instead. But line paper will work just fine. This is a coordinate plane. Okay? This is a coordinate plane. We've got an x-axis. We've got a y-axis now. So we have two axes, one going left to right, one going up and down. And I do want to be careful with that because even if I turn my paper so now they're diagonal, the x-axis is not going left to right anymore. It's kind of going up. We still treat it that way. My recommendation would be just turn the paper. You might see in the printouts that I'm going to attach to the notes or the bookwork, sometimes the lines are going in different direction. That's okay. Turn it. So one of them is horizontal. That's your x-axis. All right, so what do we do with this? Fantastic. This is where the coordinate pairs come in. If I give you a coordinate pair, let's say that, let's make it 3, 2. And I tell you that this is going to be point A. Point A is at 3, 2. Okay. Go across, then up. Go across, then up. More mathematically speaking, x, then y. This is your x coordinate. This is your y coordinate. That is the accepted way that this is done, so that is what you're going to expect to see. Again, I don't care if I turn it this way. If this is labeled as the x-axis, even though it looks like a V, if this is the x-axis, you're going to do this one first, then you do the y-axis. But we're going to do it normal to start. Okay? So point A is at 3, 2. What that means is I'm going to start at the origin, because I always originate at the origin. And I'm going to go over 1, 2, 3. Now, 3, I can imagine an invisible line that goes up, 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 perpendicular to the x-axis, all the way up forever. Okay? Not perfectly straight, but we'll pretend. Now, that's the across. I know it seems weird. I drew a line going up, but remember, I was counting across. Then I go up. I count again from the origin, 1, 2, and I picture an invisible line going on and on and on forever that way. The spot where those two invisible infinite lines meet, and you're not going to draw them every time, the spot where they meet, that is your point. That's where A goes. That is the precise location in two-dimensional space where A exists. 1, 2, 3 jumps over, and then 1, 2 jumps up. Now again, I counted from the origin, showing you it's the spot where they intersect. Most of the time you're just going to count over and then go up. For instance, if I give you, let's say, point B right here, you've got to count over first. 1, 2, 3, 4, 5, 6, 7. Looks like it's about 8. Again, it's not perfect. Ugh, that's really crooked. I'll move it over a little bit. It was supposed to be 8. Graph paper, you know I love. You know I love. And this is one of the many reasons why. Okay? We would count over 8 first. 1, 2, 3, 4, 5, 6, 7, 8. How far over from the origin is it this way? But it's not sitting on the x-axis like in Lesson 6-1. It's floating above, so we have to figure out how far above. 1, 2, 3, 4. So again, looking with this invisible line, okay, the invisible line from 8, the invisible line from B, from 4, intersect at B. So if I was going to give the exact location of B, the coordinate pair I would use would be x first. 1, 2, 3, 4, 5, 6, 7, 8. And then how far up is it? 1, 2, 3, 4. X, then Y. Across, then up. This is what we will be practicing when I see you in class next. Again, if you have any graph paper at home, it would be great to have that handy, to have a ruler handy. If you would like to print a copy of the page, you've got that as well. I'm going to go ahead and stop here. If you have any other questions, I'll cover them in class. Let me know. In the meantime, thank you, ladies and gentlemen. Have a good one.